We've discussed CI/CD at a high level, so now let's talk about specific ways to achieve quality at the source. Linting is an old term used to describe the process of identifying syntax or styling issues with a piece of code. Linters don't actually execute code, they just scan it. Imagine holding a physical printout of your code at arm's length and inspecting it quickly. You'll likely see obvious styling issues such as indentation or unintuitive variable names. You may also see syntax errors such as a missing colon or closing curly brace. You can't quite tell if the code's logic is correct, but you can catch simple problems very quickly. Linters are a great first step in testing your code. Because they don't execute your code, there is little security risk. They may even surface some security problems ahead of time. Linters are also extremely fast, often running in seconds and providing a detailed summary of where problems exist. The recurring theme here is to fail fast and early. Linters exist for almost every programming language or syntax format. I'll be demonstrating PyLint in this course. I suggest trying a few different ones, then choosing your favorite. At this point, let's use PyLint to scan the GlobalMantics CRM app source code for any issues. In my Ansible and Python network automation courses, I discuss PyLint in greater depth, but here I'll keep it higher level. Let's install it using pip first. Okay, we've installed PyLint successfully. Let's try it out on our start.py file. PyLint runs pretty quickly and reveals a list of potential issues with your code. Before this clip, I introduced some bugs. Each message has a corresponding code that starts with a letter and ends with 4 numbers. The letter indicates the message type, such as W for warning, E for error, and a few others. The number represents the error code. In this case, we have 2 issues. First, I imported OS on line 9 for no reason, which is a warning. Then, I attempted to use an undefined variable named badvar on line 13, clearly an error. You'll see we have an overall code score of 6.25 out of 10. The echo $? Prints the return code of the previous operation, and 0 means success. A non-zero return code makes PyLint very handy in test pipelines. If linting fails, our pipeline fails, giving us fast feedback. Let's see what gitdiff says. I explained how to interpret this output in the previous course. Okay, we can see the unnecessary import OS and the undefined variable. The easiest solution to fix this is to simply discard these changes using git checkout -- on the file. Let's run PyLint once more. Okay, now we see no error messages and a perfect 10 out of 10 score. The return code is 0 now, so the bash process knows linting succeeded. I want to finish up by introducing you to the config file for PyLint. Sometimes you'll want to enable stricter or more relaxed rules depending on your goals. We can generate an RC file using the callout, but instead, I'll open the file I already created, and the conventional name is .pylintrc. I won't dig into the details here, but as a programmer, you can customize how PyLint operates. The file is well commented, and many of the options become self-evident after reading about them. Next, let's talk about unit testing, the next stage in our pipeline.